In this video, I'm going to talk about weak acid, Ka, and also pKa, right? Now, according to acid is any substances which when dissolved in water produces hydrogen ion, right? As the only positive ion according to Arrhenius' definition of acid. But there's something I always talk about, that is the strength of an acid according to Bronsted to Lowry concept, which actually define acids as a proton donor, right? That is, acid is a proton donor according to definition of Bronsted and Lowry concept. Now, one thing I want you guys to understand is that the strength of an acid is the ability of such acids to donate a proton in form of hydrogen ion to a base. Now, if an acid donates a proton rapidly, that is, it donates a proton rapidly to a base, that acid is said to be a strong acid. And one of the properties of strong acid is that strong acid ionize completely in water. That is, they ionize completely in the presence of base. That is, they donate all their hydrogen ion to base, right? Now, let's now come back to this case. Now, in the case of weak acid actually ionize partially. That is, they ionize partially and do not ionize completely in water or in the presence of a base. Now, let's consider an example of weak acid, which is actually CH3COOH. Whenever I dissolve CH3COOH inside water, it's going to donate only this portion to water, because this portion is actually hydrophilic in nature. That is, it is the only portion that can actually interact with water to form. We're going to have H3O+, which is actually a complex hydronium ion, and also we're going to have CH3COOH, which is actually ethanoate here. Now, one thing I want you guys to understand is that the strength of an acid depends on its ability to transfer a proton, right? Or you simply say to transfer an atom to a base, right? To form a conjugate base. Do you get it now? Now, in this case, if you look at this guy now, this is actually this is an acid, right? This is a base, because water is basically like base here, and this was going to be is going to be conjugate acid, and this is going to be conjugate base. That's why whenever an acid donates a proton, it's going to form a conjugate base. A conjugate base is a base that have the ability to accept proton from conjugate acid and form the acid back. So that's basically what conjugate base is. While conjugate acid, they have the ability to donate a proton to the conjugate base, and they will form the base back. That's exactly what you are saying here. Now, what I'm going to do now is just to go ahead and represent this particular equation with an unknown weak acid. Now, suppose you have an unknown weak acid Ha, right? In this case, which actually, when dissolved in water, is dissociating into H plus A minus. And don't forget that the state of this particular substance is going to be aqueous, right? So all of them are going to be in aqueous. Now, if you take a look at this very well, now what I'm going to have is actually the acid dissociation constant. Ka is actually acid dissociation constant, and if I apply equilibrium law, I'm going to have constraint of H plus, right? Then multiply A minus divided by I'm going to have constraint of HA if I apply equilibrium law. Now, this expression, I'm going to hold it here. I'm going to hold it to one side here, right? I'm going to write it to one side. I'm going to have Ka, which is equals to constraint of H plus, right? Multiply A minus, right? Then divided by HA. So that's exactly what we are going to have according to equilibrium. If you write it based on equilibrium law. Now, from there, what I'm going to do here is actually to show you guys the mechanism of the reaction. That is what actually happens in the reaction. Now, one thing I'm going to be using here is actually the before and after mechanism. I'm going to have, let's say we have before here, that is before the reaction, then we have after here, after the reaction, then we have equilibrium. Normally, we might not have equilibrium, or let me just include equilibrium here, since we are talking about the ionic equilibria actually. Now, if you look at this very well, before the reaction, we are going to have this HA to be present in a particular concentration that I'm going to represent as C, right? It's just that C represents the constraint of this HA, right? Or I simply use 1, any how I like, right? I can use C, or I use 1. Now, from there, we're going to have zero amount of this that is produced, and also zero amount of this that is produced. And the reason why is that before the reaction, listen to it, before, that's that before the reaction occur, we have an unknown amount of what of HA, and we have zero amount of what of H plus and also what A minus, because they have not formed, right? Because it is still referring to before. Now after the reaction, we're going to have X amount of what of this that is going to be produced, X amount of this that is going to be produced, and we're going to have this reactant that's going to decrease by what? By the factor which is produced on the product side, which is X. So at equilibrium, we're going to have what? X, X, and we're going to have what? C minus what? X. That's what we're going to have. So putting all these parameters into what? To this formula, we're going to have what? Ka, right, to be equals to what? This is going to be X. This hydrogen ion concentration is going to be what? Is going to be X. Then multiply what? X. Divided by what? Ha is going to be what? C minus what? Minus X. Now from here, what I want you guys to understand here is that if you take a look at this very well, we're going to have this to be Ka, which is equals to what? We're going to have S squared, then divided by what? C minus X. But one thing I want you guys to understand here is that weak acid, they ionize partially in water. And one thing that happens is that if I neglect this X, it doesn't affect what? It doesn't affect the weak acid actually. If I neglect the X, it doesn't affect what? The strength of what? Of the weak acid, which is actually what? Ka, because the acid is actually what? Very, very weak. It's actually weak. So I can actually choose what to negate X. It cannot affect what? The value. So from there, I'm going to have what? I'm going to have Ka to be equal to what? S squared divided by what? C. That's exactly what I'm going to have. Right? Now, what do you think I'm going to do here? Since I'm having Ka is equals to what? Equals to S squared divided by what? Divided by C. That's what I'm having. So now from here, I cannot have what? I cannot have this. Let me simply say we cannot have S squared, right, to be equal. We're going to have K multiply by what? Multiply by C. And that is X is going to be equal to what? Root of what? Of K multiplied by C. What's going to be X? What do you think the value of what? Of X is? So X is basically the relative strength of what? Of the acid. It's actually the strength of what? Of that acid. That is basically what X is. It's actually equals to what? Root of what? Of K multiplied by what? C. So that's exactly where we are going. Now let's quickly rub this off and see what we are going to have in the next case. Now from there, we look at it very well. From here, I'm having X squared equals to what? This is going to give us root of what? Of K multiply what? C. Now from here, what do you think I can do here? I can actually go ahead and what? And let me simply say separate. If I separate, sorry, X squared is actually what? Is now X, not X squared again. Is now X, not X squared again. So if I separate, I'm going to have X to be equals to what? K raised power 1 over 2. The multiply was C raised power what? 1 over 2. That's what I'm going to have. And don't forget that X is actually the let me just say relative strength of what? Of an acid, which is a measure of what? Hydrogen ion concentration, right? So that's so that our X equals to what? Hydrogen ion concentration. That's what X is, right? You know, I said let's an unknown weak acid HA dissociate into what? Into H plus what? A minus. That's so that this is X, this is also X, and this is what? C minus X. So from there, hydrogen ion concentration is actually what? Is actually X, and that's why I'm having it what? X equals to what? Hydrogen ion concentration. So if I put it here, I'm going to have what? Hydrogen ion concentration, right, is equal. I'm going to have K raised power 1 over 2, then multiply what? C raised power what? 1 over 2. That's what we're going to have. Then from there, let's go ahead and simplify to see what we are going to have, right? So we have, since we have that case, we can actually go ahead and take negative logarithm of what? Of both sides. If you take negative logarithm of what? Of both sides, we're going to have what? Negative logarithm of what? Of hydrogen ion concentration, right? This is going to be equal negative logarithm of what? Of K raised power 1 over 2, then multiply what? C raised power 1 over 2. That's what we're going to have. So if we apply logarithm identity here, I'm going to have negative logarithm of what? Of hydrogen ion concentration, right? This is going to give equals what? Negative logarithm of what? Of Ka, right? To be specific, we have to put Ka here because we are talking about what? Acid constant, acid dissociation constant actually. So you have to put Ka here to be specific, right? So it's Ka, then we're going to have what? Here is going to be minus what? Log of what? Of C raised power 1 over 2 if you apply logarithm identity. Now from here, we can actually have this one to be, you know, negative logarithm of what? Hydrogen ion concentration is actually what? Is pH, right? This is going to be equals to what? Negative logarithm of what? Of Ka is actually what? pKa, right? Then we're going to have it to what? To be, this is going to give us minus, here we're going to have, that's going to be a log of what? Oh, sorry, this raised power of 1 over 2 actually, like there's a mistake here. This raised power of what? Of 1 over 2 actually. So I should have it to what? Let me just say, no, let me rub this side back, right? We have raised power 1 over 2 here actually. I cannot just go ahead and solve it like that. So what I'm going to be doing here is that I can actually recall logarithm identity here, that whenever I'm having log a raised power m, is same thing as writing what? M log a. Right? So that's what I'm going to apply. That's the identity I'm going to apply in this case. Now let's take a look at this, what I'm going to do now. Right? So from there, look at this. If I recall, I'm going to have what? Negative logarithm of hydrogen ion concentration. Right? This is going to be equal. I can bring down this 1 over 2. I'm going to have minus 1 over 2 log Ka. Right? Then I'm going to have what? Minus 1 over 2 log C. That's what I'm going to have. So from there, if I just apply what? pH here, so that shows that I'm going to have this word to be pH, right? Because it's actually negative logarithm of hydrogen ion is going to be equal. We're going to have what? Minus log Ka is going to be what? 1 over 2 pKa, right? Then I'm going to have what? Minus 1 over 2 log C. So this is another formula, another expression that you actually need to take note of. It is very important to take note of this formula as well. It's very important. Then from there, that's the second expression actually. Also take note of this expression that you're seeing here. And know that the value of x is actually what? Hydrogen ion concentration. That's concentration of hydrogen ion equals what? Root of K multiplied by C. This expression is also very important. It's Ka rather. So you have to know that it is what? Ka. There is another formula. So we have the two formula and also the first expression. So they are very important in order for you to determine the strength of an acid, the relative strength of an acid. So make sure you take note of the formula. I'm going to solve some question under it in a separate video, right? So you just have to take note of the formula that we actually derive. It's very important. So from there, now let's see what I'm going to do now. Right? Since I said the strength of weak acid can be determined using Ka, right? That's what we can actually use to determine the strength of the acid. Now from here, look at this. Since we have Ka here and we said Ka and also we have pKa to be equal to negative logarithm of Ka, right? So that's so that whenever there's increase in Ka, there will be decrease in pKa value. You have to take note of that, since both of them are and in logarithmic relationship, or simply you say exponential manner. So whenever there is increase in Ka, there will be decrease in the pKa value, and whenever there is decrease in pKa value, that's that there's going to be increase in the acid strength, right? In the acid strength. That's what we have. So increase in Ka, we actually increase we actually leads to we actually indicate increase in acid strength, in acidic strength. So that's actually what it means. So you have to take note of this formula. Let me just help you to write it out. We have Ka, right, to be equal to what? You have to take note of it to be S squared divided by C minus X. That's the first one. Then the second one that you have to take note of is actually is actually concentration of hydrogen ion, right, is going to be equal. You're going to have it to be root of Ka multiplied by C. This Ka is actually the acid ratio constant. C is the concentration that you have. Then from there, that's another formula. You are going to have another formula to pH equals to 1 over 2 pKa, right? Then minus 1 over 2 log of concentration. This formula is also very important. So these three formula is actually very important. You have to take note of them whenever whenever you are dealing with weak acid, Ka, and also pKa. It's very important. So this is an experiment for Ka. Right, it's very important for you to know it. Then once you get Ka, you can actually always get pKa using pKa, right, equals minus log Ka. It's very important for you to use that. It's very important. So that's just it about this video. I'm going to solve some questions under weak acid, Ka, and also pKa in a separate video. So if you enjoyed this video, make sure you give it a thumbs up, and don't forget to like and share. Thanks for watching.